Now, in summary of what we just examined, we want to use the information from the previous explorations to complete the statements here. So first of all, the y-intercept was equal to a, and there is no x-intercepts in these functions. The x-axis, we would say, is a horizontal asymptote. And our domain, x, is an element of real numbers, whereas our range, y, has to be greater than 0. However, is also an element of real numbers. Now, when b is greater than 1, the function is a growth function. And when b is greater than 0 but less than 1, then that represents a decay function. Our value of b affects the steepness of the graph as x increases. When b is greater than 1, the curve rises sharply. And when b is greater than 0 but less than 1, then the curve falls sharply. Now, if I have a value when a is greater than 1, the stretch ends up being an expansion. And so again, when a is greater than 1, so for example, when a was 2 or 5, then my vertical stretch is expanded by that factor. However, when a is between 0 and 1, then that results in a compression, such as when it was 0.5. Now, when a is less than 0, there's also a reflection, and we saw that earlier, but that happens in the x-axis. Welcome to lesson number 3. I'm actually going to start with the class examples, and then I'm going to work my way backwards. So describe how the graph of the second function compares to the graph of the first function. Now this is really similar to what we were doing with our last unit. And so if I look at how y is equal to 4 to the power of x compares to y is equal to 2 times 4 to the power of x minus 2, well, first of all, I have my y that is being mapped to 1/2 y. And after that, I have x that is getting mapped to x minus 2. Now, what this means is exactly what it meant last unit. So first of all, we have a vertical stretch by a factor of 2. But I also have a horizontal translation 2 units to the right. In this next example, I have my graph y is equal to 2 to the power of x, and then I have my translated graph y plus 4 is equal to negative 2 to the power of x over 5. So first of all, I have my x that has been mapped to 1/5 x here. I have y being mapped to negative y, and I also have y being mapped to y plus 4. And so I should put a comma to separate those. But I have these these transformations occurring. First of all, x to 1/5 x, I have a horizontal stretch. So horizontal stretch by a factor of 5, and that's going to be about the y-axis, of course. And then y to negative y, this is a reflection in the x-axis. And last, I have my vertical translation. So vertical translation 4 units down. Now, in class example 2, explain using transformations why the graph of y is equal to 1/3 to the power of x is a reflection in the y-axis of the graph of y is equal to 3 to the power of x. So I have 1/3, and this is to the power of x. Now, if we think about 1/3 and we think about our exponent laws, 1/3 can also be expressed as 3 to the power of negative 1, which is raised to the power of x. If I distribute this x into my brackets, into this exponent, this becomes 3 to the negative x. So then if I work on the replacement of x, the replacement then is x getting replaced with negative x. And if we're replacing x with negative x, this is equal to a reflection. And that would be in the y-axis. Now, in this last class example, we want to consider the function f of x is equal to 4 to the power of x plus 2 minus 6. We want to determine the domain and range of the function. Well, our domain is going to be x is an element of real numbers, because that always is. However, our range is going to change because we have this vertical stretch 6 units down. And so now, we, instead of crossing at 0, we're actually going to be crossing at a low point where y has to be greater than negative 6 now. And y is still going to be an element of real numbers. Now, the y-intercept of the graph of our function, in order to get the y-intercept, then our value of x is equal to 0. And so if we plug that into so when x is equal to 0, then y is going to be equal to 4 to the power of 0 plus 2, that's what I'm getting from up here, subtract 6. So y would equal 4 squared subtract 6, or 4 squared, y is equal to 16 minus 6, and y is equal to 10. So we would have a y-intercept equal to 10. And the equation of any asymptote of the graph of the function. Well, in this case, our horizontal asymptote does end up crossing the x-axis, and we get a horizontal asymptote now equal to our lowest point, which is y is equal to negative 6.